Okay, so we're going to go over graphing reciprocal functions today. And a graph of a reciprocal function makes the shape of a hyperbola. To graph a reciprocal function, make a table of values, substitute in positive and negative values for x, and solve for y. The parent function for a reciprocal function is f of x equals 1 over x. So we're going to graph this function and identify the domain, range, and asymptotes. So if you look down at the bottom of your notes, that is the first one. It's already graphed, but we're going to go ahead and go through how to graph it just so you can get an idea. Okay, so first of all, let's identify the asymptotes. You guys remember what an asymptote is, vertical and horizontal? It's like a borderline for your graph, and the graph is not going to cross it. It's just going to run along beside it. Sometimes the graph can cross a horizontal asymptote, but it's not ever going to cross a vertical asymptote. Okay? But even if it does cross the horizontal one, it'll still run alongside that asymptote. It's not going to go away from it. All right, so for a vertical asymptote, I'm just going to call it VA for shorthand. I'm going to take the denominator of this fraction, in this case it's just x, set it equal to 0, and solve. In this case, it's just going to be x equals 0. So that line, that vertical line, is your vertical asymptote. Okay, so if we're going to graph it, you need to use dotted lines for your asymptotes. Okay, I do want you to put them on your graph. They might not show up on your calculator if you use your calculator, but you should have them on your graph, on your paper. Okay, so then the horizontal asymptote, I'm just going to call HA. And you find the horizontal asymptote by whatever is being added or subtracted beside the fraction. So there's nothing that's being added or subtracted out here to the side of this fraction, so it's just going to be y equals 0. So you had this horizontal asymptote. Any questions so far? Your horizontal and your vertical asymptote also give you the domain and the range restrictions. Okay, so your vertical asymptote gives you the domain restriction. X cannot equal 0, because that's where your asymptote is. So using set builder notation, you're going to say x, all values of x, so that x does not equal 0. So you can use anything else, just not a 0. And then your range, all values of y, so that y does not equal 0. Okay? So let's get some values for x and solve for y. Let's start with 1. When x is 1, y is going to be 1. Okay, let's say x is 2, then y is going to be a half. What if x was a half? What would y be? 2, right. When x is in the denominator, you have to flip it and multiply it to the numerator. Okay, so let's graph those points. So those are all positive values. Okay, let's put some negative values in. That's just half of your graph. So if x is negative 1, y is going to be negative 1. If x is negative 2, y is going to be negative 1/2. And if x is negative 1/2, y is going to be negative 2. So now I'm going to get my other part of the graph. Okay. Any questions? And that's basically what a hyperbola looks like. Okay, now sometimes, see, this is your parent function. This is the simplest form of this graph. Sometimes it's going to be shifted around. So on the next part of your notes, it says f of x equals a over x minus h plus k is the general form of a reciprocal function. The vertical asymptote is x equals h. So I'm going to take this denominator, whatever that is, set it equal to 0, and solve for x, for the vertical asymptote. So when I solve for x, that's how I get the x equals h. Okay, the horizontal asymptote is f of x, or y, equals whatever the k is here. So your horizontal asymptote is going to be y equals whatever that k value is. And that's how your asymptotes get shifted around, and so your graph gets shifted around. Your domain and range restriction is determined by the asymptotes. So for your domain, you'd have all values of x so that x does not equal h. And for the range, you'd have all values of y so that y does not equal k. Okay, so let's look at the bottom of the page. Oh, and one more thing I forgot to mention. This A affects how wide it is or how narrow it is. Okay, that's all it really does. It doesn't affect where the asymptotes are shifted. Okay, just the shape of the graph. So let's look at number 2. Number 2 is already graphed at the bottom of your paper. This one, we're just going to find the asymptotes, the domain, and the range. And then I'm going to give you one that we're actually going to graph together. Okay? So you guys find the asymptotes, the domain, and the range, and I'll do it up here. Let's see what everybody gets. Okay, any questions? So for your vertical asymptote, you took the denominator, set it equal to 0, solve for x. So x equals 1 is where your vertical asymptote is going to be. Domain, all values of x so that x does not equal 1. And then your horizontal asymptote is just y equals 0. So your range, all values of y so that y does not equal 0. Okay, so let me give you a problem to graph on your own. Or actually, we'll graph it together since we haven't really graphed much anyway. So remember, your general shape is in this form. Okay, so you can add this to the back or somewhere on your paper on the front, wherever you want to. Okay, so let's get the vertical asymptote and the horizontal asymptote first. The vertical asymptote, we're going to take the denominator, x plus 5, set it equal to 0, and solve for x. So x equals negative 5 is the vertical asymptote. The horizontal asymptote is y equals whatever is being added or subtracted after the fraction. So in this case, it's y equals 3. So let's graph those two parts first. And I'm going to give this second quadrant a little bit more room because that's where my vertical asymptotes are going to intersect. That's where more of the action is going to happen. Okay, so negative 5. There's the vertical asymptote. And then positive 3. Okay, so really I just need to know where the graphs are going to start. And then I can use these asymptotes as guidelines to draw my curves. So since x cannot equal 5, I'm going to pick values on either side of that to plug in. Okay, so let's pick negative 6. If I put a negative 6 in here for x, what does y have to be? 2. Okay, so let's pick a value on the other side of negative 5. Negative 4. When I substitute a negative 4 in for x, y is going to be 4. Okay, so let's plot those points. And then I'm just going to use my asymptotes to help draw the curves. And your domain and range, before we forget about that, domain, all values of x, so that x does not equal negative 5. And the range, all values of y, so that y does not equal 3. Any questions?